Hi, so we've done quite a bit with N8N now, but we haven't touched on tools yet. And one of the most useful and important tools in our arsenal in N8N, especially when dealing with large amounts of text, is called a vector database or vector store. To explain more about what that is, let's head on over to the classroom. We're going to be going over a process called RAG, and RAG stands for Retrieval Augmented Generation. And to explain why we use RAG, it's probably best to go back to the typical approach that we're using and see where the problem is. Because say we've got this approach where we've got huge amounts of user feedback, and then we throw it into a chat window with our prompt, and then ChatGPT does some stuff, or Gemini, or whatever it is, DeepSeek, whatever it is that you're using. And then as we're asking for ideas, it gives us some ideas. So what's wrong with that approach, especially given that, Google Gemini, for instance, claim that they are able to cope with the equivalent of all 7 volumes of Harry Potter as part of the text. But the truth is a little bit more nuanced than that. The Gemini model is optimal about 3 pages. So that's a huge difference. Now, there is a little bit more nuance because there's latent and literal search, i.e., you search for the literal words and then they will be pulled out. But even so, it's a good sort of a ballpark to think of it as 3 pages as the optimal amount of context, that is, that we can use within our AI workflows. And so this is where a vector storage database comes in. And what happens there is we've got our documents. These are our documents, and the documents are the user feedback texts and stuff. And that gets broken into chunks, and then those chunks are converted into embeddings, which is like a numerical representation of that text. And then these data chunks, and the chunks are basically parts of the text, parts of the document, those are stored into the vector database. And then what we can do after that is we can retrieve stuff based on semantic similarity. So it's not like a normal database where you search for exact matches or like this, and where it has to be the exact text. This can be semantic, so it can kind of pull, okay, I get the gist of what you're after, and then it goes and fetches the relevant text based on your search criteria. And what it returns, a list of chunks that match your search criteria and a similarity score as well. A similarity score is a score as to how similar that chunk of text is to your search. If it's got a similarity score of 1, it's an absolute exact match. If it's a similarity score of 0, that's all of the chunks in the database. So as the vector storage database takes your search and then looks in the database, it will kind of go, okay, this matches 0.8, this matches 0.9, this matches 0.5, etc. In order to get started, we need to install 2 things. The first thing is our actual vector store, and we're going to be installing Qdrant. There's lots of other vector stores available. I happen to be familiar with Qdrant, so we're just going to be using that. The other thing that we need, and if we go back to this slide, we can see that we need to convert our text into embeddings. And the way we do that is we use a special kind of model called an embedding model. And the one I'm going to be picking is Qwen3 because I've been using Qwen3 for the other stuff, so why not? And specifically going to be doing Qwen3 0.6 embedding. Now, the other thing we need to know about embeddings is that there's lots of different dimensions available. So these are lists within lists. So, and then the dimensions are the number of numerical lists within lists that we can have. And they, like I said, the embedding is a representation of the text and the relationship of the text to other text. If I go to Qwen 0.6, for instance, here, it says that the embedding dimension is up to 4096, but actually, and here's a tip for you, Hugging Face is usually a little bit more accurate. So if you go to huggingface.co and then search for that same embedding model and then scroll down, we'll see that this model goes up to 1024. So that's the dimensions that it supports, this model supports. Okay, so it's Qwen 3 0.6 embedding that we need to install. So let's copy this. So this is the command to pull that model, and let's head on over to our terminal. We're in our terminal now, and let's paste that command in and just pull. And that's it. And then make sure our Ollama server is up and running, and my server is up and running. So that's all good. And now the next thing we need to do is to install Qdrant. So now let's go ahead and install Qdrant. We can install it very easily inside of Docker. So that's where we're going to install it. So as before, as we did with N8N and with OpenWebUI, we can do a search, not here, up here, and let's do a search for Qdrant. And just pick the, well, we can pick the latest, or we can pick this one, and let's just do run. And under open settings, just make sure that we put the host in there, and we copy that host in there. So we're just copying those ports over, and then let's just give it a name. Let's say Qdrant vector store. Keep things simple and go. So once we've done that, go to our local host and 6333 dashboard. We should have our Qdrant. So very simple. Okay, so let's get to the fun stuff now. Here's what we've got previously. So we've got a click start. Yep, the click trigger. It goes and fetches multiple rows. So let's start each one of those, execute each one of those nodes. And then we can see at the Google spreadsheet, it's fetched a whole bunch of rows. Great. And we've got this split out, which then gets just the, let's execute that step, just gets the tell us about your experience, and then just splits that out. Great. So we've got a whole bunch of output there. Now, when we want to put these as rows into vector storage now. But, and here's a tip for you, when you're developing, you don't want to be developing with all of the rows and feeding all of the rows in. So let's put a limit on the number of documents that we retrieve. So let's do 3. Instead of getting like hundreds of rows of data, we just got 3. So that makes things much easier to deal with. And now on the split up, we've got 3 there as well. So now we want to put these into the Qdrant store. So let's do a search for the Qdrant node, and it's this one that we want, Qdrant vector store. And what we want is to add documents to the vector store. So let's click on that. And then I've got mine connected. For yours, you would have to create a new credential, go into here, and then it would have localhost mentioned here as the URL. You just need to replace that with host.docker.internal and then :6333. Because remember, the N8N instance is inside of the Docker. And so what we want to tell N8N is look inside or outside of the Docker, look at the host, Docker's host, and then use the 6333, which is our same as our local host machine. So rest of that is fine. And then there's 2 other subnodes that we need to connect. The first one is the embedding. So let's go to embeddings, and it's going to Ollama account and pick our embedding model. Cool, that's done. And then the next one is a document loader. So we want to just load in a default document loader, and we just keep the text splitting as normal. So what that does is split the text, and you can define how it splits the text into those chunks. We're just leaving it as simple because it's fine for our use case. So now when we execute this, oh, sorry, there's one other thing that we need to do. If we go over to our vector store, localhost 6 333 dashboard, and I've already got a collection here, but we need to create a collection. So create a collection, give the collection a name, test collection, continue. What we want is a global search, a single embedding, and the dimensions is 1024. Continue and finish. And that's our collection done. So now when we go into the Qdrant vector store, we need to select our collection. So select from list collection, and then we should see our collection appear here. So let's do test collection, hit enter, and let's execute the entire workflow this time. Great. So now if we go into our test collection, we should see our documents there. Fantastic. So we've got our documents safely stored into the vector store, and I've removed the limiter, by the way, and executed the entire workflow. So all the documents are there. Next thing we need to do is to search for our data, and that's easy enough. Let's do that now. So if we create a simple chat trigger, where's our chat trigger? There it is. Move it down here. And then if we go to our data, let's pick something to search. Smoking Bones Expedition. I think that's going to be a good one to search. And now if we just open up the chat, and then here we can put in a search, bone shaking expedition. So now that's not going anywhere, obviously, because that just ends here. So now we need to create another node, Qdrant, this guy, and let's get ranked documents from the vector store. And we're going to have a Qdrant connect to our collection. And when I was testing it, I put it into test, but I've since moved it into Smoking Bones. So whichever collection you've got your latest data in, select that. You can put a limit in terms of how many items you want coming back. And then as part of our prompt, we want to move in our chat. So this is the same as the search basically. Well, before we execute that, we need to also add another subnode. With the subnode, there's two options here. We can either connect it back to this embedding, because we're ultimately using the same embedding. So that makes sure that we've got the exact same embedding being used to fetch the data as we did to store the data. So let's trigger that. Great. So what we've got back here is each chunk. So we've got the document and the similarity score, 57. And now we can do a whole manner of searches, and it would go and fetch the data from the vector store and bring it back in this nice format where we've got each chunk with the similarity score next to it. We've done something very powerful here. We've grabbed text from a Google spreadsheet and we've thrown it into a vector store, and then we're able to retrieve the relevant documents and chat to the AI. This way, we're only using the context that is relevant. We're not overloading the context window, and we're able to utilize small models more effectively.